A very good day and welcome to Failure Analysis, Advanced Technologies and Techniques. It's really an awesome day to see everybody here. We have almost 100 participants live here and also a few more on the other side on Facebook. So it's good to see each and every one of you. So ladies and gentlemen, today we'll be sharing various case studies and giving reviews, technology and facilities. On top of that, we will also explore on the TEM and STEM key technologies and discuss their importance for semiconductor device imaging and analysis application. Right at the end of the webinar, I'm going to help you grow your knowledge and expertise, but you have to wait right till the end. Are you ready? Okay, before we begin, there's some house rules to observe. As you can see on your screen, please pay special attention to the Q&A box, as you can type in your questions there and not into the chat box. So that's got to be very clear. And each speaker will be having about 30 minutes of presentation and about 15 minutes or so of Q&A. So it depends. But of course, we'll try to make it sweet and nice for each and everyone. We of course have 4 distinguished speakers, and here's a quick look at our program for today. It starts from Dr. Suhairi to Siti to Dr. David, all the way to Dr. Alex. And of course, right at the end, we got something very exciting for everybody in this community. So with that, ladies and gentlemen, are you ready? Let's begin our webinar, Failure Analysis, Advanced Technologies and Techniques, with our very own first speaker. Dr. Suhairi Saharudin has a doctoral degree in fiber laser research from University Putra, Malaysia. Dr. Suhairi has been working as a researcher at Suhairi Berhad and MIMOS Berhad for more than 20 years. He is among the founder of IEEE Photonic Society Malaysian Chapter. He is also the chairman of Fiber Optics Society of Malaysia. His presentation is filled with videos and will make this an interesting segment. His presentation will be on an overview of failure analysis. With a brief introduction, ladies and gentlemen, I present to you Dr. Suhairi. Over to you, Dr. Suhairi.
All right, thank you, Lawrence, for your kind introduction. Okay, Assalamualaikum and salam sejahtera to everyone. My name is Suhairi, and I will begin the session with a walkthrough and overview of MIMOS failures analysis capabilities and facilities. Allow me to start by emphasizing our role as government agency that supports national interest in providing infrastructure that contribute to the success of economic activities in Malaysia, which we hope would facilitate the growth and competitiveness of our local industries, be it locally or internationally. We also hope to be able to contribute in sustaining foreign investment in Malaysia with our extensive and reliable failure analysis services. And finally, as a national research institution ourselves, we also play the role to facilitate and help the adoption of technology by providing analytical services to our R&D communities in research institution and also academia. With existence of more than 20 years now, we have grown to become an entity similar to other world-class institutes, such as A-STAR in Singapore, E3 in Taiwan, KIST in Korea, and IMEC in Belgium. Our facilities are well maintained and according to the highest standard, highest quality management system, which we obtained since year 2000. And our lab are also accredited with ISO 17025, which acknowledges the competency and validity of our testing and calibration results nationally and also internationally. For example, E3 Taiwan has validated our measurement process through interlab measurement comparison, which are actively involved in our activities. And it has been accepted for use by the Taiwan Nanotechnology Industry Development Association, TANIDA. We also are proud to share that the lab is accredited for nanometer measurement using a transmission electron microscope under ISO 17025, which allow us to perform nano measurements under the equipment category. Our customer base consists of industry, academia, and a research institute, and our business has grown over the years with an accumulated numbers of customers of more than 6,000 customers over the periods of 7 years. You can find us in our campus, which is strategically located in Kuala Lumpur, inside Technology Park Malaysia in Bukit Jalil, which have easy access from both north and southbound of the highways. The lab itself is situated in a controlled clean room environment, which allow us to maintain strict adherence of sample handling procedure, which is very critical in nanometer measurements. Moving on, one might ask, what would it take to be successful in FA process? Well, we can speak based on our established and long history involvement in this field, and our experience has led us to believe that in order for the service to be well accepted by customers, three elements should be given emphasis upon, which is the process flow, right tool for the analysis, skill, and experience. But before further deliberating these three elements, allow me, for the sake of our audience who are not familiar with the field of failure analysis, for me to share a few slides about failure analysis. Some of the ways to appreciate the field of failure analysis is through watching TV series, such as, if you can still recall, a series like CSI or Air Crash Investigation, you'll find that the content are very scientific and technically challenging, which could improve our problem-solving skill, especially to those in technical areas. I would like to bring an example of the role of a failure analysis engineer or analyst, for that matter, with a story that is close to our heart, but yet to be close, at least for the loved one. This is about the unfortunate tragedy of MAS airline, which went missing in year 2014. One of the evidence found on the beach of Reunion Island was a part of aircraft known as flaperon, and failure analysis engineer uses tools such as electron microscope and also energy dispersive spectroscopy to determine whether the part is indeed from the missing aircraft. And this is done by identifying the chemical elements from the part and comparing it with the paint used for the aircraft, which is unique for MAS Boeing 777 aircraft. In yet another unfortunate event that took place in the same year, Malaysian Airlines aircraft flight MH17 was shot down while flying on Ukraine airspace. And this incident unfortunately took away all the life of its passenger. And similar approach were being adopted in determining the cause of crash by comparing the paints from the found wreckage with paints element from a type of a missile. And in the analysis, it was found that the identified paints matches with the paint of a recovered missile parts. And this finding led to a hypothesis by the Dutch Safety Board that the downing of flight MH17 was caused by missile launch from a back surface to air missile system. So you see, forensic science and failure analysis resemble very much in the sense that it involves collection and analysis of data in order to find the root cause of failure. And it is done so that corrective action can be undertaken. A failed IC chip can also cause human losses due to a failed system. Imagine failure of an electronic device caused by IC defect in an autonomous vehicle that soon will revolutionize our mode of transportation. Certainly that outcome will be fatal when it involves accidents. So the process of determining cause of failure is essential in semiconductor industry, at least from the perspective of production yield. And there are many areas that need to be examined as far as a single chip, IC chip is concerned. Among others are contamination on the surface or inside IC dies, shorted or lifted wires, voids, cracks, and delamination, to name a few. Now, let us come back to our early questions of what constitutes a successful failure analysis. From our point of view, among the most important aspect of it is the process flow itself, which should conform to standard and quality practices. In our case, as I mentioned earlier, our process are strictly governed by quality management system, which ensure our process are systematic and consistent. We are also adhering to world-class standards such as ISO 17025 that sets out the requirement for a competent, impartial, and consistent operation of result from our lab. And our impartiality are manifested in various roles such as supporting the activities in nano-verified program. Secondly, we believe a full suite of analytical tools are essential that can provide customer with the right choice of analysis for their requirement. Nevertheless, as with other failure analysis lab elsewhere, there are instances when specialized analytical equipment are not available. But thanks to our extensive networking with more than 18 lab partners, we are able to provide other services that are not found in our service portfolios. Finally, our workforce of almost 20 people and our involvement of 20 years in this field, we are confident that we are able to provide you with satisfactory services and results, inshallah. And we also always maintain a good relationship with other experts in this field to form a network of subject matter experts in this country. Here in MIMOS, we adopt a process flow with steps that require us to always consult our customer to ensure their requirements are met at every stage of the FA flow. In general, there are three types of processes that require different category of equipment, which is the electrical failure analysis, physical failure analysis, and material failure analysis. And at each step, there are multiple techniques that can be adopted for the respected analysis. And the customer may define which technique are best for their needs, or in the case when there's no specific method specified by the customer, our subject matter expert will provide assistance to make the right choice and sometimes striking the balance between cost and lead time for the service. And much like a situation when a doctor is presented with a patient's symptom, IC failure analysis begins with narrowing the possible root cause of problem through validation of symptom using basic tools such as a curve tracer, which is a common piece of test equipment in semiconductor industry. And at this stage, the customer will present to us symptoms of failure such as current leakages, open or short circuit, and we will validate that symptom prior to the next action. For condition when structural integrity of a device cannot be compromised, for reasons such as evident in a dispute case or for whatever reason in terms of keeping the integrity of the samples, a non-destructive method of defect isolation can be employed using, for example, X-ray imaging. And from X-ray imaging, we can identify visible faults such as shorting, lifted wires, or even percentage of voids in BGA balls. Additionally, we can also use 3D X-ray imaging to reconstruct a 3D virtual cross-section view inside a failed device without damaging the package. For a situation when internal structure of a device need to be revealed or exposed for further identifications of defect, we provide various techniques for IC package opening, such as wet etching or laser decapsulation. And sometimes human skill are still needed when it comes to locating a target in a device where a slow process of revealing defects is in IC is necessary. In this case, we offer mechanical polishing, which although crude and time consuming in process, but are very effective when combined with our X-ray and 3D X-ray equipment, which make a difficult task such as exposing a defect easier. Another important step or tools in identifying fault in IC packaging is the use of fault localization equipment such as thermal emission microscope. Again, just like in medicine, when a person, excuse me, when a person need to be diagnosed for symptoms such as cancer, the patient need to undergo MRI scan, where the possible diagnostic of tumor existence can be ascertained. Similarly, in the case of IC chip, symptoms of faulty device presented during earlier electrical verification can be further elaborated by observing any excessive heating, which indicates a high current flow, which may be due to defect or abnormalities like dielectric ruptures, metallization short, or leaky junctions. Of course, the fault isolation result will be just an image without much information in it if no action is taken upon. Once the possible fault has been localized, we can, for example, perform a FIB cut to create shapes that is known as a lamella using an equipment known as focus ion beam to etch or mill specific area in the specimen. The prepared lamella can be further analyzed by an electron microscope, in this case to reveal, for example, contact rupture at the localized area, which indicates possible cause of a short circuit. Later in the following presentation, my colleague will share with you a unique application of FIB, another unique application of FIB that can perform circuit device modification. Next is the physical analysis process. This process involves magnification of features that is hidden from our naked eyes, and basic magnification tools such as digital or laser microscope are common in our analysis, but for higher magnification analysis, electron microscope is employed, and which can help bring up the image magnification up to about 1 million times of magnification. For example, this FSM image allows us to magnify a foreign matter hidden inside an IC, which otherwise would not be observed under the view of a normal digital microscope. Besides the function to magnify features such as contamination of foreign material, electron microscope also can provide to a certain degree quantitative values such as length and diameters of the features under observations. In this case, diameters measurement of a nanoparticle. Again, using medicine as an analogy, once tumor is identified through MRI scan, medical doctors need to ascertain whether the tumor is indeed cancerous. This is done by performing a biopsy. Similarly, once contamination or foreign material are identified in specimen through image magnification at a specific area of interest using, for example, microscopy tool, what other information can we obtain? How do we arrive to a conclusion? So this is the stage in our general failure analysis process flow where we hand over the task to our friends in the material FE lab, where they will further investigate and provide quantitative information on types of material found in the specimen. So there are various types of spectroscopy equipment which can be used for this purpose, and among them are XPS and AES and TOFSIM, in which are categorized as surface sensitive analytical equipment, where we can study those atoms which are located near the surface instead of atoms in the bulk, which are well away from the surface. Later, again, my colleague will explain further some application using this type of equipment in her presentation. So in general, our analytical equipment are categorized into 3 labs according to its functions: electrical, physical, and material. And at each lab, we have our subject matter expert who perform a related analysis for our customer on daily basis. So as such, you can trust them with their expertise in handling your sample and also your analysis. So the question is, with so many method and equipment available, which one is the most suitable for your analysis? As a general rule of thumb, you may ask yourself whether you just need to see the features, the causes of the failure. So in this case, equipment which falls under the category of microscopy is all what you need. You can magnify the image to your liking and to a certain extent can derive some quantitative information such as thickness and length of the features that you are observing. Or does your analysis requires more information related to the type of material existed inside the samples? So in this case, spectroscopy type of analytical equipment will best suit your requirement. But if this information is still not enough, don't worry. For starts, my colleague will provide you with some insight using 5 case studies in which several options of equipment are possible for specific analytical requirement following my presentation. You would also want to directly channel your analysis requirement or inquiry to our lab director herself for technical explanation, or probably to get some information on our pricing scheme for each analytical service offered. We also provide public and customized training in failure analysis from time to time, and you can use this opportunity to expand further your knowledge or your subordinates in the exciting field of failure analysis. So in summary, I have covered a general overview of failure analysis process based on our general FA flow. And at each stage, there are options in terms of technique or equipment that you can employ for your analytical requirement. The flow is universal and it is applicable not only in semiconductor field, but also, for example, in material sciences. In fact, we receive quite a lot of samples which are non-semiconductor related. So I urge all of you to get in touch with us for your failure analysis needs. And I hope this short presentation is informative enough for you and look forward to serving you with our FA service. Thank you very much.
Thank you, Doctor. How's things over there with you? Good?
Yep, fine.
Good, huh?
As expected.
And for all those who just joined us, hi. Welcome, everyone. It's good to be with you here in this webinar, and we hope that this webinar will be a start to a new relationship between us and you. Okay, we have a couple of questions here. My first question, Dr. Su,
Yep.
do you work with universities, and could you please explain a little bit about that?
Oh, certainly. We have a lot of engagement with the university for their analytical services for a reason, because we provide a very short lead time, and there are instances where when the lecturers or professors would like to publish their result fast, so they have to wait for quite a time in the university to get their queue. So we are an alternative for a fast analytical result for the university. So of course, we deal a lot of analytical work for the universities. For those who are interested, you can directly communicate with our business person, Miss Amy. So she will actually explain the costing and also the all sort of arrangement that require for university.
Okay, another question, Dr. Su. What about people? I mean, MIMOS is based in Kuala Lumpur. What about people in Penang, and how do they get in contact with you or any of your colleagues?
If you are talking about sending the sample to Kuala Lumpur, well, I mean, with this all this COVID-19 problem that you have, we now realize that there are so many other alternatives that you can send beside couriering the sample to MIMOS. But we are looking probably opportunity one day to also have our presence in the northern region. That is again subject to the government's approval, but we foresee that it is beneficial for the industry at the northern region to have a close physical infrastructure that can actually assist them with their analytical services. So we look forward one day for our presence in the northern region, inshallah.
Okay, I'll take one last question here. What are the limitations of different FA tools?
Okay, this is something that is very tricky because each of the FA tools have their own strength, and always the case of whether it really suits for the particular analysis or not. But there are times when we have to balance between the fast lead time and also the cost. So the only limitation that I can foresee with respect to the tools that we have, we have three categories: electrical, physical, and material, is the cost. You can have a fast lead time by performing cross-section using FIB, which is costly, or you can have a slower process, which is cheaper, using a mechanical polishing. So that's the sort of constraint that you have whenever you want to choose between the various failure analysis equipment.
Okay, then thank you, Dr. Su. It looks like we have a couple of more questions. We will, of course, try to answer all of them, but because due to time limitations, I'd like to thank Dr. Suhairi. He will get back to you on your questions. Okay, and Dr. Suhairi will join us back again as a moderator for the rest of the session. He will also answer some of the, or rather provide some of the questions to our panelists later on. So with that, thank you, Dr. Suhairi.
Welcome, Lawrence.
Thank you.